Hello, this video is going to work through a hypothesis test from soup to nuts. We will look at how we can set up our hypotheses. We will look at how we can figure out what our sample estimate should be. We will also look at how we can use stat key to make a randomization distribution, how we can find the p-value from the randomization distribution, and then how to use that p-value to make a conclusion about our hypotheses. Okay, so the example we're working with is a company claims that the mean time it takes an employee to evacuate the building during a fire drill is 45 seconds. The evacuation times in seconds for 25 randomly selected employees are listed below. We want to know, is there strong evidence that the mean evacuation time is more than 45 seconds? Now, the first step in doing a hypothesis test is to set up our hypotheses. Whenever we see something that says, is there strong evidence that, whatever follows is going to be the alternative hypothesis. So here, I see, is there strong evidence that the mean evacuation time is more than 45 seconds? Okay, so that's my alternative hypothesis. Now I need to write this in terms of the parameter. The parameter of interest here is going to be mu, because it's a mean, and it's going to be the mean evacuation time for all employees. Now, so I want to know, is there evidence that the mean evacuation time is more than 45 seconds? So my alternative is that mu, the mean evacuation time for all employees, is greater than 45 seconds. And my null hypothesis is that the mean is equal to 45 seconds. Okay, the next thing that I should do before I do anything else with the hypothesis test is make sure that we have specified a significance level for the test. Choose a cutoff. What are we going to need? How small a p-value do we need to reject the null hypothesis? And I'm going to choose my significance level to be 5% alpha. So my significance level is 0.05. Okay, so there's my significance level. Finally, before I use my randomization distribution, I'm going to want one more thing. I'm going to want to know what my sample estimate is that I'm going to use to determine whether or not this sample provides strong evidence that the mean is greater than 45 seconds. Since my parameter of interest is the population mean mu, I am going to estimate that population mean using the sample mean. The sample mean has the notation x bar, and if I calculate it by taking the mean of all of these values over here, I get 52.08 seconds. Okay, the next thing I'm going to need in order to test these hypotheses is a randomization distribution. Since it's not given to me, I'm going to need to create it using stat key. So let's look at how we can do that. Okay, here we are in stat key. Now, the randomization hypothesis test section is over here. And this is where I'm going to find the buttons that I need in order to create my randomization distribution. So because my hypotheses are about just one mean, mu, I'm going to click on Test for Single Mean. Now, when I come in here, my pop-up blocker is not working. I'm not sure why. Let's see. So when I come in here, I can see that there is data already loaded in. but it does not reflect my actual sample. And since none of these built-in data sets are my evacuation times data, I am going to need to edit the data and put in my own sample data. So I'm going to get rid of the body temperatures. Oh, there we go. And I'm going to put in a header row to tell it what my sample is looking at. It's evacuation times. And then I'm going to put in my data. Now I could either type these in or paste them in depending on the situation. I'm going to paste them in and click OK. So now the original sample that you see over here, this original sample is the sample from my data. It's got the mean of 52.08. It's got 25 observations. The next thing I need to do before I can generate randomization distribution is to make sure that the null hypothesis reflects the one that I want to test. Now, if you recall, our null hypothesis is that the mean is equal to 45 seconds. So I need to click on here and change my null hypothesis to 45 and then click OK. Now I like to do one more check before I start generating samples. I check to make sure that my original sample reflects the data that I'm working with, and it does, and that my null hypothesis reflects my null hypothesis, mu equals 45 seconds, which it does, and now I'm ready to generate samples. Now I'm going to want to generate 5,000 samples, so I'm going to click on the Generate 1,000 Samples button 5 times. 1, 2, 3, 4, 5. Okay, now the next step is going to be to just take a look at this and make sure it makes sense. My null hypothesis is that the mean is equal to 45 seconds. So this distribution, this randomization distribution, is showing me the distribution of results for the sample mean that I would expect to occur just by chance if the mean is really 45 seconds. So it should be centered around 45, and it is. I can see the mean of this randomization distribution is very close to 45, 44.964. So that's good. I make sure I've got enough samples. Yep, I've got 5,000 samples up there. Now, what I'm going to do with this distribution is I'm going to look for my sample estimate, 52.08, and I'm going to say, okay, how unusual would it be? Is this something that is likely to occur just by chance? Or is this something that is so surprising, so far out in the tail, that I say, gee, I don't think this null hypothesis is true. Now, the way that I'm going to do this is I'm going to go back and look at my alternative hypothesis. My alternative hypothesis here is that mu is greater than 45 seconds. This means that I'm looking for the right tail of the distribution. If my hypothesis were that mu is less than 45 seconds, I'd be looking at the left tail, the bottom portion of the distribution. And if it were not equal to, I'd be looking for the area in both tails. But here, the mean is greater than 45 seconds is my alternative hypothesis. So this is a right-tailed test. So coming back in here, I'm going to click on right tail. And it's going to always pop up with 0.025 and then some cutoff value. This is not what we want. We want to know how extreme our sample estimate is. Our sample estimate is not 55.040, it's 52.08. So I need to click on here and put in 52.08. And once I do that, I can see that it calculates my p-value for me. It tells me what percentage of all of these dots, or what proportion really of all these dots, are at 52.080 or beyond. And my p-value here is 0.088. So now I can come back in. My p-value is 0.088. Was that right? Yes, it was. Okay. Now, to make a decision about my hypotheses, I compare this to my significance level. Since my p-value is greater than my significance level, that means that I do not have strong enough evidence to reject the null hypothesis. So this means that there is not strong enough evidence to conclude that the average evacuation time is greater than 45 seconds. As a note, this does not mean that we have strong evidence that the mean evacuation time is 45 seconds. It only means our sample estimate was 52.08, which is more than 45 seconds, but it's not enough more to give us strong enough evidence to say that it couldn't have happened, that it was that much more than 45 seconds just by chance, when in reality, the true population mean is 45 seconds. I hope this example helped you. If you have questions, please feel free to let me know. I'm happy to answer them, either about this example, about a homework question, or anything else. Thanks.